Welcome to the channel. This is Digital Electronics 2, and the lecture entitled Boolean Function Implementation of CMOS Logics in DSCH Simulation. Before jumping into the simulation, we need to know certain basics to help you build a proper logic circuit first. To build a logic circuit, we are going to use PMOS and NMOS. PMOS is constructed with the P-type source and drain and an N-type substrate where holes are the main carriers. NMOS consists of N-type source and drain and a P-type substrate where electrons are carriers. If you give 0 to PMOS, it turns on and the NMOS turns off. If you give 1 to NMOS, it turns on and the PMOS turns off. Using many PMOS and NMOS, a circuit is built. To complete the circuit in an easy way, we are going to place PMOS network on top and network of NMOS at the bottom. Remember, the one with dot is the PMOS and V naught is the output. The arrangement of the MOS depends on the mathematical expressions. If multiplication, we keep NMOS in series and PMOS parallel, and then vice versa for addition. If your Boolean expression doesn't have a bar on top of it, then you have to pass the output through a CMOS inverter. If it does have a bar, then take output without the inverter. Now let's dive into DSCH simulation. To give you a brief overview, right-click for drawing the connections, left-click for component movement, and on the right side you have the library with your components. To remove something, use the gun button in top left corner, and click what you want to remove. At first we place the triangle thing, which is the 5-volt supply. Then, we drag out the PMOS component and place it on the board. Since B and C is in addition, they will be in series. And A is multiplied with both, so it's parallel to both B and C. C and D are multiplied, so they will be in parallel to each other. They together will be in series to the previous terms as it's getting added. For the NMOS network, both B and C are parallel with each other, and A is in series to both. C and D will be parallel to the whole previous terms. Since the expression has no bar or complement, the output is fed into the CMOS inverter, as we have discussed earlier. As you can see, the circuit works at the moment. To see if the circuit gives the correct output, we pass known input values to the expression. If we give A and B as high, the output is high, the light will turn on indicating high. If we give A and D as high, the output is 0 and the light will be off.